Walaikum salam. Walaikum salam. Assalamu alaikum to everybody. In the previous class, we were discussing about first drawback of thermodynamics, and we have reached a conclusion that it is never possible to have complete conversion of heat energy to work. And while trying to create a path where we can say, sir, somehow I want to make efficiency one, Carnot has taken a very specific type of challenge and he has done hypothetically some discussion. We have made it. But ultimately, we got a conclusion that yes, efficiency of any motion machine can never be equal to one. It is always less than one. Hence, we have first drawback of first law of thermodynamics. It fails to explain the extent of conversion. How much is converted? Total is converted according to first law. But we say no, it's not like that. Only a part of heat energy can be converted to work. Remaining will be unavailable energy. Remaining energy is called as unavailable energy. Then the question comes, what will happen to this unavailable energy? How this unavailable energy has to be visualized. For that purpose, when we were discussing the story of Carnot cycle, we got one final conclusion that there is a term known as Q reversible by T, and this term is found to be a constant quantity, and to that constant quantity we have given a name, entropy. Yes. Now let us go ahead. Once you are using the word entropy, your first objection or doubt, sir, what is this entropy, right? And what is the mathematical meaning of this and what is the physical meaning of this? Both of these are very important, very important. Entropy as a whole topic is very useful for us with respect to examination point of view. It is also very useful if you are having a scientific approach to enjoy the beauty of nature. Come on. What is entropy? Just now I said that if suppose, for example, I am having 200 joules of heat energy and I have supplied this 200 joules of heat energy to a system, then I am expecting 200 joules of work. It is possible. Is it possible? No, never possible. I have given you homework of 25 questions. Remember that out of those 25 questions, it is not possible to say, sir, I have completed all, but there are certain good students and sincere students say, yeah, I have attempted all. But in nature, students are supposed to be of all types available. Nature is a mixture of everything, right? In which we have people with a positive mentality, people with a negative mentality, right? Therefore, remember that out of this 200 joules, I can utilize, say, for example, 180 joules. What happened to the 20 joules? This 20 joules of energy will be going out to the surrounding. Okay, sir. Is it available to utilize it? No, I cannot utilize that energy. Hence, I have given the name unavailable energy, unavailable form of energy. And what will happen to that energy? Once it goes to the surrounding, it will create disturbance in the surrounding. It will create disturbance in the surrounding, right? Sorry to say, but a beautiful example which is suitable to our classroom was once before this password and what we can say through mail ID, the process has been done by the management. Everything is going calm and quiet. And in this case, I am thinking that I am able to give very perfect efficiency. And you may be also enjoying the class that, sir, we are getting perfect efficiency. On the contrary, if you go back, I am trying to supply 200 joules of heat energy, but because of some unnecessary radical elements, right, of our society, what happened? Number of classes have been disturbed. Unavailable energy will disturb the universe. Unavailable energy must be used in a proper way. Yes, sir, it is always used in a proper way, but In nature, whenever we are supplying heat energy to a machine, then out of the supplied heat energy, a part of heat energy will be going to surrounding that unnecessary, unwanted, right, elements of the society. They will create trouble in the society. They will destroy the society. They will disturb the society. Society get disturbed. Universe get disturbed because of this unavailable energy that is measured in terms of entropy. Okay, what is entropy? Entropy is a measure of disorderedness. Yes, I was now trying to visualize that scenario when the people of your class, those unwanted bloody idiots, what happened? Sir, they have created unnecessary nuisance in the class, and number of times we have wasted our class. What is that energy? Unwanted energy, unavailable energy. It's not useful in a proper way. That is increasing the disorderedness of our class. Disorderedness. Orderedness, consider ice cube. Water molecules are closely packed together. What is that solid known as? Solid system is known as ordered form of matter. Very much systematically arranged together, ordered form of matter. No, sir, I have kept ice cube on the surface of table and I'm not doing anything, simply automatically, right? Automatically, supermarket language. Spontaneously, it is converting to water. Liquid water is having molecules far away from each other. What is the meaning of that? Disorderedness is increasing. Yes, sir, entropy is more in case of liquid water. Try to enjoy the meaning of word disorderedness. Then I kept it water as it is on the table surface, sir. It is decreasing slowly. What is happening? It is getting evaporated. Vapors, molecules are very much disordered form. Therefore, I used to enjoy one sentence in my classes that most disciplined form of matter, solid. Most indisciplined form of matter, gaseous state. And wherever you have indiscipline, there will be more disorderedness. Wherever we have more disorderedness, people say entropy is more. Yes, now we got an idea, sir. Unavailable energy will be creating a disturbance in the universe. And that disturbance or that disorderedness is measured in terms of a thermodynamic property known as entropy. Yes. What is entropy? Come on. When you write the word entropy, number one, what is entropy? Sir, entropy is a measure of disorderedness. Yes. Number two, how do you measure this? Sir, entropy is given mathematically by Q by T. What is Q? Amount of heat energy involved. Take care of my language. I am saying neither released nor absorbed. I am saying involved. But it is always taken as Q reversible by T. Entropy is Q reversible by T, right? Amount of heat energy involved. Why we are saying reversible? Because we have taken Carnot cycle. All the processes are supposed to be reversible. Therefore, it is Q reversible by T. Next, what are the units of this? Sir, SI units, joules per Kelvin. No, sir, let us take in terms of calories. It is not CGS system. It is not CGS system. ERG is CGS system, right? We measure calories per degree. Nowadays, people are using a modern unit known as EU, entropy unit. What is entropy unit? One entropy unit is equal to 1 calorie per degree. 1 calorie per degree is also named as 1 entropy unit. Fine. Next, what is S? S is entropy, is an extensive property. What do you mean by this? Sir, I know very well. I have done it in first part of thermodynamics. It depends upon bulkness of the matter. It depends upon the quantity of matter. It is said to be an extensive property. No, sir. If you go further, it is a state function. Very nice. When you say the word state function, yes, sir, I know it. It is independent of path chosen for the conversion. It depends upon initial state of journey, final state of journey, whatever with the path you have adopted. We don't have any independence on the path chosen for the conversion. It depends only upon initial state and final state of system. Right now, this is the brief introduction of the entropy. Then we'll try to enjoy a beautiful way of discussion in entropy, because it is a conceptually and mathematically very, very essential for both doctors and scientists. Okay, once you are saying that entropy, then the question is, sir, if you are saying it is a measure of disorderedness of matter, then how do you enjoy this? For that purpose, come on, let us take some examples where I'll try to say or try to enjoy how do you proceed for entropy understanding, right? I am saying understanding of entropy, but I am discussing 4 marks in each line, okay? For example, H2O, H2O, H2O. Listen carefully. Solid, liquid, and gas. We are going from ice to liquid water and then to vapor state. Now tell me what is happening as I am going this side when I am moving from H2O, ice cubes to vapors. What is happening? Sir, entropy is increasing. Entropy increases. This is one example. But since you people are genius, therefore I'll give one step ahead. When you observe this process, conversion of ice cubes to liquid water and then to gas form of water, do you think that are you applying any effect of temperature or pressure? No, sir, I have done nothing. I have just kept the ice cubes on the table surface. Spontaneously, they are converting. Okay, now try to conclude 2 sentences. Sentence number 1, when I am going from ice cube to liquid water and gas, entropy is increasing. No, sir, whenever I am having a spontaneous process, entropy is increasing. Yes, I got a very beautiful statement. In all spontaneous processes, entropy increases. In all spontaneous processes, entropy increases. What do you mean by the spontaneous process? A process which takes place by itself, or a process which has been initiated and left, it will continue. Yesterday we have done one example for that, burning of coke, right? So in case of spontaneous processes, entropy increases. By the way, all natural processes are spontaneous. Who are you? You are a natural process. Today I have taken a tablet, therefore I am growing, sir. Today I forgot the tablet, therefore I am not growing health-wise and physical-wise. No, it's not like that. You are growing, you are a natural process, right? And all natural processes are irreversible. You cannot go back to yesterday's class, right? Sometimes what happens in our classroom, there are some beautiful discussions going on. Sir, please show me previous slide. Entropy never allows you to show the previous slide. All natural processes are irreversible. They are unidirectional. And remember, all natural processes are spontaneous processes. Next. Okay, let us do like this. Instead of writing star here, make an enjoyment in this way. A. Okay, very nice. B. Suppose, for example, if I am, sir, I am increasing temperature. What will happen? I am just discussing continuation of this topic. No, sir. If you increase the temperature, intermolecular force of attraction decreases. If intermolecular force of attraction decreases, people go away from each other. What people? Molecules. Molecules will go away from each other. As they are going away, disturbance. Entropy is more, right? They are closely packed. Disturbance. Arrangement is very good. Orderedness. Therefore, if intermolecular force of attraction decreases, entropy increases. Now there is a problem with MPC students. What is the problem? I don't want to see your videos. Please don't try to make fool of you, right? Simply just listen, right? बीच-बीच में वीडियो ऑन करना बंद करना, बदरों की हरकत मत कीजिए, इंसानों की तरीके से सुनिए, नहीं पसंद आना तो go to hell. I don't care. If you increase temperature, intermolecular force of attraction decreases, entropy increases. यहाँ mathematically आपको क्या difficulty होगी, sir? S is equal to Q reversible by T. Therefore, if you increase temperature, inversely proportional entropy should decrease. No, never. Because if you increase temperature, you can say entropy decreases. It is inversely proportional provided Q is constant. No, Q is not a constant here. As you change the Q value, temperature also changes. Therefore, apparently, whenever you are seeing any mathematical equation, instantly don't apply conclusions as we say, okay, upar raha, numerator directly proportional, denominator inversely proportional, cut, 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 over. No, negative marks will be automatically available with that. Therefore, remember, if you increase temperature, disturbance increases, thermal agitation increases. Therefore, entropy also increases. Nice. Next. Suppose, for example, I have taken a solvent, right? And I am adding solute to a solvent. Nice. Whenever you are adding this one, what is the process known as? Formation of solution. Now tell me, during formation of solution, what happens? Nothing, sir. Initially, I am having sugar particles in my hand, solid particles. Entropy is less. Disorderedness is less. Now I am adding it into water. What is happening? They are getting dissolved. They are getting dispersed in the whole available container. During formation of solution, entropy increases. Try to visualize the examples and try to enjoy, because they are supposed to be the examples possible as 4 marks to us. Next. Suppose, for example, I have taken a reaction. HCl is enjoying a game along with the silver nitrate. The name of the game is chemical reaction. And there is a formation of HNO3 and AgCl. And go back to your 10th class teacher told you that AgCl is precipitate. Nice. Now the question paper examiner will ask you, what will happen to entropy during this process? Sir, this is liquid, this is liquid, this is also liquid, but this is precipitated. Precipitated means they are settling down. They are settling down means they are getting ordered. Entropy decreases. Therefore, what you can make general statement? During all precipitation reactions, yes, during precipitation reactions, entropy decreases. Right? Next. Suppose, for example, you are saying, sir, we are having reaction of mixing of gases. If suppose we say, sir, we are having mixing of gases, then what will happen? Naturally, you are having a classroom in which already we are having 50 students sitting from MPC stream, and because of combined class 1 Arif Hashmi sir came, come on boys from BPC, BPC, come and sit here. What happens? Disturbance increases. As the number of molecules increases, disturbance increases. Remember, whenever this word comes, mixing, always entropy increases. Is it not mixing of solute and solvent? Yes. Therefore, remember that whenever we are having mixing of the process, entropy increases. However, sir, this is also mixing. No, this is a chemical reaction. Mixing is a physical process. Therefore, whenever you are having mixing of any 2 or more substances, entropy increases. Next. Suppose, for example, if I am enjoying an experiment that is given something like this. That, sir, I have 2 vessels. Go back to gaseous state. We have done this. Problems we have done. Now I am doing the experimental discussion. Suppose, for example, if I am connecting these 2 containers, and there is a wall available here. We are having left hand side bulb, gas 1, left hand another bulb, gas 2, right? Come on. Now, if you remove this wall, then what happens? The available volume is doubled, of course, but the gas molecules are having more space to enjoy, so they will try to run this and that side. What happens? Entropy increases. What do you mean by that? Sir, class is going on. Physical chemistry class is going on. All 100 students available, and all of them are sitting calm and quiet because the rhythm of the subject is going very systematically. So everyone is trying to absorb, because you people are good students and disciplined students. Therefore, you are having calm and quiet. What is entropy? Less. Entropy of the classroom is less. Class is over. One leg of the lecturer is one outside, one leg is still inside. What happens? Shouting started. Shouting started. What is happening? Entropy increases. No, sir. Lunch bell has been rang up. What will happen? Everyone is available in the campus. Entropy is furthermore. They are just going this and that side to toilet and corridor and lunch box and all that. What is happening? Disorderedness increasing. No, no, sir. Home bell is over. At 5 p.m. we are going home. One is going to Dabilpura, one is going to Secunderabad, one is going to Mehdipatnam, one is going to Tulich. What is happening? Entropy is increasing. So when you have available space, gas molecules have a profit to enjoy the whole space. Hence, once you open the wall, then of course, volume is also increasing. At the same time, number of moles have more freedom to move. Therefore, entropy increases. Still, we have some more beautiful examples. First, write down this, then we'll proceed. Okay. Go ahead. Try to enjoy the beauty of entropy. It's a beautiful topic. Don't learn the subject as if we are doing some work. No, sir, we are playing a game. And the result of the game is a better and good rank. Shall we proceed? Please slightly go faster. I am having meeting on 3:30. I have to finish at 3:25 only. Is it over? Yes, very good. Now, let us go to next one. G. Suppose, for example, I'm asking you, I have 2 moles of oxygen and 3 moles of oxygen in the same vessel. My question is entropy of this and entropy of this. What you will say? Sir, definitely 2 moles will have less disturbance, 3 moles will have more chance to enjoy the game. Therefore, entropy is less in case of 2 moles and more in case of 3 moles. What is the meaning of that? Okay, sir, I got a conclusion. As number of moles increases, entropy increases. Sir, it is quite obvious because S is extensive property. It depends upon Bulkness of matter, it depends upon quantity of matter. Whether you are having 2 moles of oxygen or 2 moles of nitrogen, it makes no difference, sir. If number of moles increases, entropy also increases. Next, let us enjoy a game like this. So suppose, for example, if I am having 3 moles of oxygen, see how the example has been finely, beautifully created. 3 moles of oxygen and 2 moles of ozone. Come on. Yes. How do you proceed? Sir, 3 moles of oxygen, 6 gram atoms. 2 moles of ozone, 6 gram atoms. No. Here, this is a unit. Mole of oxygen is unit. We have 3 moles. Therefore, entropy of 3 moles is more than that of this one. So entropy is more where we have more amount of quantity. Take care of this example properly. Next. Suppose, for example, you are saying, sir, I am talking about gases which are something like this. I have taken neon. What is atomic mass? I'll write here 20, right? Mass number. Atomic number is not interested here because the extensive part depends upon the bulkness of the matter. And here we are having HF. What is molecular mass? Molecular mass is 20. 1 plus 19, 20. Please don't say that this is atomic number. I'm writing below so that you can have similar behavior. Come on. Now I'm asking the question, sir. Entropy of neon, 1 mole of neon, entropy of 1 mole of HF. How do you proceed? Very simple, sir. Here we have 2 atoms, here we have 1 atom. Therefore, entropy of neon is less than entropy of HF, even though molecular mass is same. What is conclusion? Sir, conclusion is, okay, what is the conclusion? As complexity of molecules increases, nice. As complexity of molecules increases, entropy also increases. Got the point? Entropy increases if you are increasing the complexity. Okay, once you got this, then in your mind something is dancing. Sir, is it something like this? That suppose, for example, I have taken nitric oxide, I have taken nitrogen dioxide, I have taken nitrogen sesquioxide, I have taken nitrogen pentoxide. Sir, what do you think about it? Complexities goes on increasing. Therefore, entropy of NO less than entropy of NO2, less than entropy of N2O3, less than entropy of N2O5. Yes, as complexity increases, the entropy value also increases. Okay, fine. Once you are saying the word complexity, then there is a small problem here. What is the problem? Let us enjoy this one. As molecular weight increases, some people say like this, as molecular weight increases, entropy increases because entropy is extensive properties, or molecular weight is increasing, therefore it is also increasing, right? If it is so, let us take an example that we are having H2O, H2O and HF, right? Just now see the previous example, what we have said. So if suppose you are increasing the molecular mass, it is increasing. If we are understanding like this, then here what is the molecular mass? Molecular mass of water is 18 and molecular mass of HF is 20. Then what we expect? Very simple, sir. The entropy of water should be less than entropy of HF, right? Molecular weight. But remember that when we are discussing this here, we are having more complexity. Therefore, you may say, sir, no, not like this. Apart from molecular weight, you should take another property also. So don't take only one-dimensional discussion. Try to enjoy all the concepts. Slowly I'm developing. Now I'm coming to a stage, complexity versus molecular weight. Here we have more complexity. Here we have 2 atoms. Here we have 3 atoms, right? Therefore, I should say the entropy of water should be more than that of HF. But there is a problem. What is the problem? Sir, hydrogen bonding. Here, because of hydrogen bonding, it gets associated. Water is associated liquid, right? I have to enjoy this in his larger space. So I'm writing once again here, entropy of water, entropy of HF. When I am discussing molecular mass, then molecular mass of H2O is less, molecular mass of HF is more. Therefore, at first instant, I am thinking that entropy of HF is less than entropy of H2O is less than that of HF because molecular weight is less. Then I shifted my vision. Sir, there are 3 atoms, there are 2 atoms available here, therefore complexity is more. Then I should say, okay, entropy of water should be more than that of HF. Further, I am visualizing, no, sir, here we have hydrogen bonding. Here also we have hydrogen bonding. Go to Krishna Mohan sir class that he says chemical bonding, the hydrogen bonding is available because of that water is said to be which liquid? Associated liquid. Right? No, sir, here also we have hydrogen bonding. Then Krishna Mohan sir says, no, but it's not like this. In case of water, we are having electronegativity of oxygen less, electronegativity of fluorine is more. Hence, here in this case, we have weak hydrogen bonding. Here we are having strong hydrogen bonding. Then he will say one beautiful sentence. What he will say? He'll say, in case of water, we have weak hydrogen bonding, but extent of hydrogen bonding is more. Extent of hydrogen bonding is more. Here we have strong hydrogen bonding, but number of hydrogen bonds coming out are less, right? He is trying to explain you the old story of childhood that it is used to have in your lower classes textbooks. एक लकड़ी लेके टूट जाएगी, 4 लकड़ियां लेंगे नहीं टूटेगी. Same thing. Even though we are having 4 sticks, weak stick but put together. Hydrogen bonding is very weak in water, but extent of hydrogen bonding is more. Therefore, boiling point of water is 100 degrees centigrade and boiling point of HF is 19 degrees centigrade. Therefore, inorganic people call HF as low boiling liquid. It is called low boiling liquid. Therefore, with respect to all this beautiful discussion, entropy of water is said to be less than that of HF. Because when we are discussing HF or H2O, it is associated liquid. The reason here in this case is association. I'll write this word, greater extent of association. Association through, you people are genius, you can understand that, through hydrogen bonding. Next. Suppose, for example, if I have taken something like this, that molecules are having symmetrical nature and unsymmetrical character, then naturally as symmetrical nature increases, we have more orderedness. Okay. There is one more typical example I have selected. Suppose, for example, roll number 1 is saying, sir, I am increasing of a substance 25 degrees centigrade to 35 degrees centigrade. Roll number 2 say, no, sir, I am increasing from 75 degrees centigrade to 85 degrees centigrade. And now the discussion is going on between those 2 students where you have more entropy change. Delta S, here also we have del S, here we are having del S, change in entropy is more, right? Roll number 3 says, difference in temperature is same, therefore they should have same change of entropy. Remember, entropy change is more here and entropy change is less here. Sir, what is the problem? The problem is when you reach 75, already this fellow is in disordered form. Already it is in disordered form. No, it is ordered form. I am having a scope of making disorderedness. I am having ordered form. I am having a scope of making disorderedness. What about this? It's already disordered. एक murder हो चुका है. और 2 कर लीजिए, नो प्रॉब्लम, चलेगा. मच्छर मारने की सलाहियत नहीं है, मर्डर करने चले हैं. क्या होगा? डिसऑर्डरनेस इज वेरी हाई. Therefore, a beautiful 4 marks question has been created. What is that? Del S. Entropy change is more. Like this. For same rise in temperature, that is the basic requirement. Del S is more. At which range? At lower range of temperature, because there is a scope of getting disorderedness. ये तो already disordered हो चुका है, और क्या करेंगे? थोड़ा बहुत और करेंगे, ठीक है, लेकिन यहाँ पे चांस ज्यादा है. Therefore, remember that for same rise in temperature, delta S is more at lower range of temperature. Advanced examination, multiple answer. Doctors, yes, it is a single answer question for you. Next. Suppose, for example, if you are saying, sir, presence of hydrogen bonding and absence of hydrogen bonding, entropy, of course, you know that one. Wherever you have presence of hydrogen bonding, association, therefore entropy decreases. Now, suppose, for example, you are having something like this. I'm having free expansion, free isothermal, 4 marks question, yes, expansion of gas. Right? One fellow is asking you questions like this. Number one, he'll ask you, what is the amount of work done? Let us enjoy the beauty of thermodynamics. Sir, free expansion, no work is done, because what is the meaning of free expansion? Free expansion means external pressure is zero. We are expanding in vacuum. Next, they will ask you, what is del E? You say, sir, isothermal process, del E is equal to zero. And then both of these are zero, then you say, sir, Q is equal to zero. Then you say, sir, del H is also equal to zero. And then they will ask you del S. What will happen? Sir, gas is expanding. Whatever be the condition, the molecules are getting disturbed. Therefore, entropy never equal to zero. Entropy is always increasing because it is a natural process. Once you keep the gas open vessel, it goes on expanding. This is a question, 4 marks question. Remember the whole factors we have discussed. Next. Okay. Suppose, for example, you are saying, sir, I am having, you have not finished solid state. However, I'll write down here in this case one example. S, entropy of graphite and entropy of diamond. Yes. Then the question comes, sir, what do you think about entropy of graphite and entropy of diamond? Again, please go back to 4th group elements, inorganic chemistry. What Krishna Mohan sir says, graphite is having sp2 hybridization. We are having hexagonal layering structure, and the layers can slip over each other. Therefore, graphite is used as lubricant. Whereas in diamond, we are having sp3 hybridization, and it is supposed to have close packed tetrahedral structure. And it is loosely packed, and layers can slip over each other. Layers can slip over each other. Entropy is more in case of graphite as compared to that of diamond. Right? Next. Suppose, for example, you are taking, sir, I have taken ammonium chloride. Who is that fellow? Solid. And I'm adding into water. This example already we have done. Sir, we have formation of ammonium chloride solution. And we know that wherever we have formation of solution, entropy increases. Next. Suppose, for example, I am having, sir, this is O2. I am supplying energy so as to get 2 nascent oxygen atoms. What happens to entropy? Remember that entropy is more because number of particles are increasing. What that fellow will ask you, that fellow will not give like this. During atomization, yes. When you say, yes, atomization causes increase in entropy. Okay, next. Suppose, for example, you are discussing that you have taken carbon and you have taken water. This fellow is in solid state, this is in liquid state, and we are getting carbon monoxide plus hydrogen, and this is called water gas. Suppose you are having gas here and gas here. Now the question is, what happens to entropy during this process? Sir, solid ordered form of matter, very less entropy. Entropy is less. Entropy is slightly more, but when you say gases, entropy is very high. Therefore, entropy increases during such type of chemical reactions. What you have to learn, if number of moles are increasing, gaseous state, entropy goes on increasing. Okay, next. Suppose, for example, I have given you nitrogen, diatomic gas, and I have taken this gas at dash atmospheres, say for example 10 atmospheres. I have kept the same gas and now I am saying that no, N2 is available at 1 atmosphere. What is going on? Pressure has been decreased. When pressure is decreased, expansion takes place. Entropy increases. During expansion, we have increase in entropy. Okay. Write down this, then we'll proceed. Tell me if it is over. Finished? Very good. Come on. Sayyidul Rahman. Come on, go ahead. Yeah, 3:15. Yesterday also I pointed out, today also. Running out. One boy is there, he's asking entropy constant for adiabatic process. First of all, he don't know any unnecessary things he is trying to ask. Entropy constant. Who or where you got this word entropy constant? There is no word like entropy constant in the universe. Right? And first of all, first criminal mistake. Second criminal mistake, entropy of adiabatic process. Who asked you about adiabatic process here? You are in nursery. With respect to entropy, you are in nursery, so behave like a nursery student. Try to learn. Entropy constant, you are doing a crime. Come on, next. जितना पढ़ा रहा हूं उतना समझ गए तो समझो आप अल्टीमेट पहुंच गए. अल्टीमेट उसको नहीं समझ के तमाशा करना बेकार है. चलो कोई बात नहीं. अभी है अपने पास एलिमेंट्स, अनवांटेड एलिमेंट्स. S T. No problem. I don't require sorry. I don't require thank you from anybody. I require respect to the subject. Don't respect me. Respect to the subject which I am delivering to you. There is a beautiful example here. People ask this question. Let's see how they created the situation. Raw egg. And it is boiled. During conversion of raw egg to boiled egg. All of you listen, there is no word in the universe called entropy constant. I said entropy is a property. Its value is constant for a given process. It is not a constant. It is not equilibrium constant like situation. Okay? Wrong information, deal mat kijiye. Behave like a normal, systematic. जो पढ़ा रहे हैं पूरा ध्यान उसी पर है. सर ऐसा, इसके बाद ये बोले, इसके बाद ये बोले, इसके बाद ये बोले. Full stop. That's all. चलिए. What you can think about this one? Normal thinking क्या होगी? Conceptual sir, raw egg का मतलब है इसके अंदर थोड़ा सा liquid type का material है, semi liquid type, semi solid type का, और boiled egg it's a tough substance, hard substance. I can throw the boiled egg anywhere. So common sense क्या बोलेगा? Sir, entropy should decrease because I am getting from liquid to this type of situation. लेकिन ऐसा नहीं होता है, ये याद रखना है. Remember, entropy of boiled egg, when I am saying this side, right? Entropy of boiled egg is more. हमको क्या समझ में आ रहा? Less. ये more है. क्यों more है? ये एक sentence है. What I said. Scientist, आप सिर्फ word enjoy करो. And doctors, you can enjoy the beauty of this word in your biological science classes. Denaturation of protein takes place. Why entropy increases? Denaturation of proteins. कभी ये word आया क्लास में आपके तो थोड़ा सा beautifully enjoy करो biological science के faculty से. Sir, ये क्या problem है? What is the meaning of denaturation of protein? उसमें होता क्या है? If they say you hota kya hai, they can understand, yes sir, because of this entropy is increasing, right? Similarly, there is one more example to keep it in our mind. Stretching of rubber. Structure of rubber something here. Okay, pura likhiye. Stretching of rubber. Common sense kya bolega? Sir, if you stretch the rubber, molecules are going away from each other. When the molecules are going away from each other, disorderliness should increase. Entropy increases, right? लेकिन ऐसा नहीं है. Entropy decreases. ये चीजें याद रखना. कैसा decrease होता उसका reason ये है. ये कुछ ऐसा रहता है. DNA के type का ऐसा कुछ रहता है. अब ये end और ये end को पकड़ के मैं खींच रहा हूँ. तो ये दो जो coils हैं इसके, ये करीब आएंगे. Are you understand? Once I am stretching that rubber, this is called uncoiling of macromolecules. इसका जो concept है वो है uncoiling of macromolecules. वो आपको समझ में नहीं आएगा, इस वजह से ये समझ में आएगा. If you stretch these two ends, these two lines will come close together. Entropy decreases. Reason लिखिए. No one is going to ask you reason. Uncoiling of macromolecules. What is a rubber? A polymer, a macromolecule. Macro, बड़ा macromolecule. ठीक है? Yes. That is the way with which we try to enjoy what is the meaning of physical meaning of entropy. Yes, today I have tried on my level best to enjoy the meaning of entropy. Now this is conceptual side. अब हम क्या करेंगे, मैथमेटिकल साइड पे जाएंगे. भाई किसी वाले पसीना आना शुरू हो गया, नहीं, कुछ भी नहीं है, सिंपल है. डेरिवेशन को हम अवॉइड करेंगे, कंक्लूजन लेंगे. आईआईटी वाले डेरिवेशन को भी एंजॉय करेंगे. ठीक है, that will discuss in the next class. Take down this much, that I will stop here. Thank you. Assalamu alaikum. Any doubt to ask? Read textbook to enjoy the theoretical background of the concept of entropy. जितना आप ज़्यादा पढ़ेंगे, इतना मजा आएगा इस टॉपिक में. हमको एक आदत डाली गई है स्टूडेंट्स को कि नोट्स पढ़ लीजिए, काफी है, बहुत है, मेरे नोट्स इतने अच्छे हैं, मैं इतना अच्छा. ये सब बेकार बातें हैं. नोट्स पढ़िए, उसके बाद बुक्स पढ़िए, टेक्स्ट बुक्स पढ़िए. एंजॉय द लैंग्वेज, एंजॉय द ब्यूटी, हाउ दे आर रिप्रेजेंटिंग. वो एक अलग दुनिया है, एक अलग दुनिया. ये गलत इंफॉर्मेशन आपको दी गई कि सर कुछ भी नहीं करना है, खाली नोट्स पकड़ के रहना है. ठीक है, लकीर के फकीर बन के रह जाते हैं. आपको दुनिया देखना है तो बुक्स उठाइए, टेक्स्ट बुक्स उठाइए. Enjoy the meaning, how they are representing. They will say same thing. Things will be same, but way of representation is different. Shall I pack up that? Is it over? Thank you. Bye.